In this video, we are going to look at the problems in the chapter 11-1 slides. So we'll start here on page 4. We want to write these products. I've written all of these problems on a separate page so that we can do this without having to flip back and forth. So here we go. First, we want to multiply y to the fourth by y cubed, and that's just going to be a matter of adding those exponents. So that's y to the 4 plus 3 is y to the 7th power. Next, we've got a times a squared. Well, remember, that's a to the first times a squared. So that's a to the 1 plus 2 is a cubed. Next, we've got b times b. Well, that's the same as just saying b to the first times b to the first, or b to the 1 plus 1, which is b squared, and you guys should have known that one anyway, since if we multiply two b's together, we get b squared. Down here, we've got x times x cubed times x squared, so that's x to the first times x to the third times x squared, which gives us x to the 1 plus 3 plus 2, or x to the 6th. For e, we have x squared times y cubed, and that's just x squared y cubed. We can't combine terms with different bases. Finally, we have f, which is 5x cubed times 2x to the fourth. Okay, well, I can multiply my 5 and my 2, and multiply my x cubed times my x to the fourth. So that gives me 10, and then I've got x to the 3 plus 4. So that's 10x to the 7th. Next up, we have these problems on page 5. We're asked to reduce or simplify the fractions, perform the division indicated by each fraction. So here we have the 5 problems. X to the 5th over x squared. Remember that this is the same as subtracting their exponents. So that's x to the 5 minus 2, which gives us x cubed. Here we've got a squared over a, which is, of course, a to the first. So it's a to the 2 minus 1, which is just a. We've got b to the 7th over c to the 5th. And again, we have different bases here, so we can't do anything with this, and that stays the same. Here we have m cubed over m cubed, so that's m to the 3 minus 3, which is just m to the 0. And remember that if we have anything that is not equal to the 0 divided by itself, we get 1. So m to the 0 equals 1. Finally, we have y cubed to the divided by y to the 4th. That's y to the 3 minus 4, or y to the negative 1, which we will find out is 1 divided by y. Next up, I've got two separate sheets here. In these first problems, we're going to write the quotients using positive exponents, and then in the second set of problems, we will simplify the expressions and make all of the exponents positive. Okay, so we'll start with x to the 5th divided by x to the 8th. That would give us x to the 5 minus 8, which is x to the negative 3. But since we want to have positive exponents, we move that into the denominator, and we've got 1 over x cubed. A over a to the 4th, that's a to the 1st minus 4th. That's a to the negative 3, which is going to be 1 over a cubed. Y to the negative 3 over y squared is y to the negative 3 minus 2, which gives us y to the negative 5th, or 1 over y to the 5th. X to the negative 3, x cubed over x to the negative 5th is x to the 3 minus negative 5, which is the same as x to the 3 plus 5, or x to the 8th. They don't always wind up in a fractional form. Finally, we've got 12 over 8 12 times x to the 7th over 8 times x to the 5th. With our 12 over 8, we're just going to simplify those as much as possible by dividing each by 4, which will give us a 3 in the numerator and a 4 in the denominator. And then we've got an x to the 7 over x to the 5th, which is x to the 7 minus 5, or x squared. So 3x squared over 4 is our solution. The next set of problems, we're just simplifying these and making sure that all of our answers have positive exponents. So a squared b cubed over ab to the negative first, that's going to be equal to a to the 2 minus 1 times b to the negative 3 minus negative 1, gives us a to the first times b to the negative 2, or a over b squared. For b, we have xy to the negative 1 over xy squared. So that's x to the 1 minus 1 times y to the negative 1 minus 2. That gives us x to the 0, y to the negative 3, or 1 over y cubed. Finally, for c, we get to something a little different. We've got a sum in the numerator, x cubed plus y squared divided by xy. And the first thing we can do here is to simplify this by breaking it into two fractions. This is the same as x cubed over xy plus y squared over xy. Well, then we can simplify each of those pretty easily. We've got an x cubed in the numerator and an x in the denominator, so that leaves us with an x squared in the numerator and our y in the denominator, plus y squared over xy, that's y squared over y is just y, divided by x. And there we go. Next up are these 4 problems on page 9. We're asked to find the powers of powers by first writing each expression as repeated multiplication and then applying the multiplication law of exponents. Here we go. Have a good weekend. Okay, so this is going to be 3 to the 2, or 3 times 3 cubed. So that's 3 times 3 times 3 times 3 times 3 times 3, which is 3 to the 6th power. And if we really want to do that out, it's 729. We won't have to worry about for the rest of these because we've got variables instead. Here we've got x cubed to the 4th. So that's x times x times x raised to the 4th power. That's x times 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 x, or x to the 12th. A squared squared is a times a squared, which is a times a times a times a, or a to the 4th. And finally, n cubed to the 5th. I am not even going to bother to write out 15 n's. I'm sorry. That's just n to the 15th power. Next up, this is on page 11. We're asked to raise these fractions to the indicated powers. Remember, when we're raising a fraction to the indicated power, we raise the numerator to the power and the denominator to that power. So here we go. We've got 2/3 squared. So we take 2 squared over 3 squared, which is 4/9. Negative 3/4 squared. We square the negative 3 to get a 9. We square the 4 to get a 16, 9/16. Negative 1/3 cubed. Negative 1 cubed is negative 1. 3 cubed over is 27, so that's negative 1/27. Sometimes it helps to put a circle around your negative sign so it doesn't blend into the fraction bar. x over y cubed cubed is x cubed over y to the 3 times 3. So that's x cubed over y to the 9th. And then finally, we have x squared over y cubed to the 4th is x to the 2 times 4 over y to the 3 times 4, which is x to the 8th over y to the 12th. Next, almost done. You've got these 6 problems on page 12, which ask us to raise the products to the indicated powers. Here we go. We've got ab squared, so that's a squared b squared. A squared b quantity cubed gives us a to the 2 times 3 is a to the 6th, b cubed. Xy squared quantity squared is x squared y squared squared, so that's y to the 4th. 3x squared, 3x quantity squared is 3 squared, which is 9 times x squared. 2x squared y quantity cubed is 2 cubed, which is 8. X squared cubed is x to the 2 times 3, which is 6, y cubed. And negative 5 xy squared, we just square everything in there. Negative 5 squared is 25, x squared, y squared. Our last set of problems, we just have 2 of them. We want to simplify these expressions and write with positive exponents. Something there, yes, okay. Okay, so for this first one, we've got 12x cubed times x squared over 18x to the negative 5th. So if I combine everything in my numerator, that's 12x to the 5th over 18x to the negative 5th. 12 over 18, 12 and 18 have a common factor of 6, which will give us, if we divide each of those by 6, we get 2/3. And then x to the 5th divided by x to the negative 5th, that's x to the 5 minus negative 5. So 2/3 x to the 10th. We could also write it as 2x to the 10th over 3, but I kind of like it better this way. Next, we've got 5 to the negative 2 times d quantity cubed. So that's 5 to the negative 2 times 3, or 5 to the negative 6, d cubed, over 5 to the negative 4, d to the negative 2. Okay, well then that's 5 to the negative 6 minus negative 4, d to the 3 minus negative 2. Negative 6 minus negative 4 is negative 6 plus 4, so that's 5 to the negative 2. D to the 3 plus 2 is 5. So that is, in the end, d to the 5th divided by 25. That is it for this video. If you have any further questions, please get in touch.